Introduction to OpenGL. Why should we use OpenGL and not ray tracing? Ray tracing seems more physically based, so why don't we use it to design a graphic system? Well, it is possible to use ray tracing, and it is actually simple for simple objects such as polygons with simple point light sources. In principle, using ray tracing, we can produce global lighting effects such as shadows and multiple reflections, but ray tracing is very slow and it is not well suited for interactive applications. To produce a decent resolution image, we will have to trace millions of rays, and some of them might not end up entering our lens. Having said that, practical ray tracing with GPUs is getting close to real time, and modern GPUs are able to perform ray tracing. So what is OpenGL? OpenGL is a platform independent application programmer's interface, shortly known as API. It is close enough to the hardware to get excellent performance in terms of time and perform real-time rendering. It focuses on rendering and gives sufficient flexibility to the programmer to render different types of objects. The OpenGL architecture is simple and easy to use. It provides a link between the low-level graphics hardware and the high-level application program that you write. This is where the application program sits, and here is the graphics API, the OpenGL. Here are the drivers of your hardware. It basically communicates between your program and the drivers to produce the required renderings. There are different versions of OpenGL. Latest versions are completely shader based, while earlier versions of OpenGL came with default shaders. Current versions do not come with default shaders. Each application must provide both a vertex and a fragment shader. This basically means that you must additionally write a vertex shader and a fragment shader program. OpenGL ES is suitable for embedded systems. The ES here stands for embedded systems. So version 1 is a simplified version of OpenGL 2.1. Version 2 is a simplified version of OpenGL 3.1. OpenGL 4.1 and 4.2 added geometry shaders and tessellator. Version 4.6, which was released on 30th July 2017, is still the latest version. WebGL is a web-based version of OpenGL. It is a derivative of OpenGL ES version 2. It provides JavaScript bindings for OpenGL functions, allowing an HTML page to render images using any GPU resources available on the computer where the web browser is running. WebGL is not included in our curriculum. OpenGL has multiple libraries. The OpenGL core library, which is OpenGL 32 on Windows and GL on most Unix systems, it provides basic functionalities such as defining primitives. Then there is the OpenGL utility library. It provides functionality in OpenGL core so as to avoid rewriting code. Defining textures and MIP maps can be performed in OpenGL utility library. So it basically builds on top of the core library. OpenGL also provides links with windowing systems. GLX is for X window systems, WGL is for Windows, and AGL for Macintosh. OpenGL Utility Toolkit, or GLUT, provides functionality common to all Windows systems, such as opening a window, getting input from the mouse and keyboard, menu items, and event-driven programming. Code is portable, but GLUT lacks the functionality of a good toolkit for a specific platform. For example, it does not have slidebars. GLUT was created long ago and has been unchanged. Amazingly, it still works. But some functionalities can't work since it requires deprecated functions. Free GLUT updates GLUT. It has added functionalities such as context checking. Glue is an OpenGL extension wrangler library. Glue makes it easy to access OpenGL extensions available on a particular system. It avoids having to have specific entry points on window code. Application only needs to include glue.h and then run a glue init command. So how do you know which function is in which library? Well, you don't. You don't need to memorize the functionalities of different OpenGL libraries. Instead, you decide on your objects, lights, and camera. Then work out which OpenGL functions are required to implement these. Then include the libraries that contain your required functions. These are all practical programming issues, and you will have the OpenGL documentation to help you.